Now we're going to do some calculations with the normal distribution. I'm going to go back and use that file of Galton's with the heights of the parents and the adult children. And I want to do some calculations with the height. I'm going to suppose that they're normally distributed. We're going to plot it later on and show that that's true. But first, let's go ahead and compute the z-scores for these heights. Now, you have to be careful when you compute the z-score. It's important to realize that you're using the population mean, mu, and you're not using the sample mean. Okay, this is not x bar, the sample mean. This is mu, the population. And I'm assuming that I know this. I don't. We're going to see later on that there are ways that we can assume we know the population mean, but technically speaking, I don't. I only know the sample mean. And I'm going to assume I know the population mean. That's sigma. So if I want to be really careful, whenever I use Greek letters, I'm always talking about things that are associated with the population and not the sample. So mu is the mean of the population. Sigma is the standard deviation of the population. Okay, let's go ahead and compute the z-score. So I'm going to take my data value, subtract it from the mean, divide by the standard deviation. And I'm going to want to use that drag down command to do the same for all of these values in the same column, which means I'm going to have to anchor my population mean and my population standard deviation. And I'm just going to pull that down now. And there we go. And I'm going to go ahead, I'm just going to format these, although it's not a big deal. Control-Shift down. Format, number, and again, I'll just go out to 1 decimal place. Okay. So that's how we're going to compute the z-scores. Let's compute some probabilities. So the probability that a randomly chosen data value is less than or equal to 69, I'm going to use norm.dist, right? Because I really want the percentile. This is what a percentile is. So I'm going to put 69 in here. Whoops. The height, the population standard deviation, and I want the cumulative. So basically, there's a 70% chance you're going to draw an adult child that has a height less than or equal to 69. Now notice that when we compute probabilities, we don't care about the equal sign on the inequality because the probability of a single point is 0, so I get this one for free. Oh, because, never mind. It dragged these down, I think. Hold on. 69, K3, K4. Oh, I didn't anchor these, that's why. So let me just go ahead. I'll just copy and I'll paste this as a value. There we go. Okay, I want the probability that they're greater than 61 inches. Well, notice what this is. This is equal to 1 minus the probability that it's less than or equal to. So this is actually equal to 1 minus the probability that I'm less than 61 inches. Okay. Because the probability that I'm greater than 61 inches and the probability that I'm less than 61 inches has to add up to 1. And I can go ahead and compute this. Now this will be 1 minus norm.dist. My data value is 61. Population mean, population standard deviation, and we always click true. Okay. So notice what I'm actually computing. I'm computing the upper percentile, right? The percentile for 61 would be the probability that you're less than or equal to 61. So this is the upper percentile. And the other problem is basically the same. I'm just going to say, okay, what is this? Well, this is 1 minus the probability that x is less than or equal to 72. And so I know what this is. This is 1 minus norm.dist for 72. Population. And there we go. And again, that's the upper percentile. So this is in roughly the 9th upper percentile. This is in the 95th upper percentile. Okay, now there were a few problems on the homework that were kind of strange. They asked you to find the probability that a randomly chosen value was between two specific values. So here, I might want to know what is the probability that a randomly chosen value is between 68 and 62. And you realize this is the probability that you're less than 68 minus the probability that you're less than 62. And if you're not sure that that's true, draw out a little sketch. You can convince yourself that's true if you draw out a little sketch. So first I'm going to compute the percentile for 68. Okay. And now compute the percentile for 62. So 62 is my data value, x. And I'm just going to subtract them. So my final answer will be this minus this. Now notice, I could have done everything on one row. Okay. I could have written this all in one row. I could have said, okay, this is equal to norm.dist. Whoops. And I could have calculated it for 68. Okay. And then subtracted it from 62 on the same line. And that's perfectly fine. Whatever, is easiest for you. Okay. And notice, whoops, hold on. I need to do that. There we go. Okay. And notice I get exactly the same answer. I can put all the commands on one line, or I can do them separately and subtract them. So this is going from, right here, this is going from a data value to a percentile. Okay. Now sometimes I want to go the other way. I want to go from the percentile to the data value. So I might want to know, okay, what height is the 25th percentile? In other words, what height is 25% of the population less than? And now I'm going to use norm.inv, right? So the percentile is going to be written as a probability. And actually I don't need any true. And this gives me the data value. And I can check that. If I do norm.dist on this, I should get 20.25. Okay, I won't check it, but you might want to. Again, norm.inv, 75th percentile is going to be 0.75. And then the mean, standard deviation. And that's the value. And this makes sense that this is in the higher percentile, so the data value must be larger. And it is. 99th percentile, we'd expect to be larger than both of these. And we should, whoops, I clicked the wrong one there. Okay, 0.99. And it is. Okay, so these are the basic calculations we're going to do. We're going to be computing z-scores. We're going to be finding the percentile for data values. And then we're going to be finding the data values for percentiles. Those are the main calculations that we're going to end up doing.